why phenol is more acidic in nature, why it is more acidic than alcohol. As I've drawn the structure of phenol over here, the carbon attached to the benzene ring is sp2 in nature because it is forming a double bond with the adjacent carbon atom. But over here, the alcohol has carbon which is sp3 in nature. As we know that sp2 overlap is greater than sp3 overlap. So in sp3 overlap, the hydrogen from the hydroxyl group is loosely attached. So this will donate hydrogen ions more easily. But over here, the carbon attached to the oxygen group is attached to oxygen's lone pair. Now these lone pairs will participate in the delocalized pi electron system of benzene. So positive effect will be observed, meaning the lone pairs of the functional group will participate in the resonance effect. So this will be hyperconjugation will be observed between lone pair pi sigma pi system, and the O negative lone pair will shift to electropositive carbon atom and yield express more quickly than on attack of nucleophile. The main reason of it is resonance, because phenol is resonance stabilized. So if we see that the conversion of phenol to phenoxide ion, over here the H plus ions will be yield and then the lone pair will be left. So this will hyperconjugate itself and produce 5 resonating structures. Now if we compare resonating structures of phenol and phenoxide ion, we see that the phenoxide ion is more stable and provides more delocalization. Why is that? Because if we see that this is phenoxide ion and it has a lone pair over here, this is going to shift over here, this lone pair is going to shift over here, and then all these 5 resonating structures will be obtained. But as for the phenol, the hydrogen is going to stay attached. So this will bond over here, make a bond over here, and then this will become positive because it is occupying its lone pair. The bond is occupying the lone pair. So now this will shift over there, and then a positive charge will develop, and then all of these structures will remain. But in phenoxide ion, the positive charge doesn't develop. There is an ease in shifting the negative charge toward the ortho pair positions. So this will provide the stability. But whereas in phenol, there is a charge separation between positive and the negative, which is the pi electron. So this is an unstable species. So this phenol has vacant orbital, which is this one, and electron cloud would feel attraction towards it. This electron cloud would feel attraction towards it, and hence this will form an unstable species. So that would mean that phenoxide ion is more stable than the phenol and will be more acidic. So effect of substituents and acidic nature of phenol. As we know that positive ion effect is observed, which means that lone pair donation effect is observed in phenol and there is electronegativity attraction. So what groups will yield will provide increased acidic nature of phenol? Minus M and minus I groups. Minus M meaning the resonance attraction groups that are actually electron withdrawing groups. So that would mean that minus I effect groups also that have electronegativity attraction, they also will increase the acidic nature of phenol. So as we know that mesometic will win in inductive effect, because if we see that we have an halide group attached to it, a halide ion is more electronegative than the carbon atom. So this will